Welcome back. Today we're diving into a really cool physics shortcut. I mean, it's an idea that's so simple it almost feels like you're cheating. But here's the thing, it's the key that unlocks our entire understanding of the electrical universe. So let me ask you this. What could a swirling galaxy, literally billions of miles across, and a single speck of dust possibly have in common? It really does sound like a riddle, right? But the answer? Well, it reveals one of the most fundamental tricks physicists use to make sense of the world. Just think about a map for a second. A city, let's say New York, is this incredibly complex place, right? You've got millions of people, endless streets, towering buildings. It's a lot. But on a world map, it's just a dot. To understand where it is relative to, say, London or Tokyo, we simplify. We have to. We trade all that overwhelming complexity for some essential clarity. And that exact same idea, trading complexity for clarity, is precisely what we need when we jump into the world of physics. Because, let's be honest, it is full of messy, complicated shapes and interactions. Okay, just picture trying to calculate the electrical force between two charged objects that aren't perfect little spheres. I mean, imagine every single charged particle on the surface of one object is pushing and pulling on every single particle of the other one. The math for that is, well, to put it mildly, a complete and total nightmare. So how in the world do physicists deal with this? Well, just like that map maker, they have this incredibly elegant shortcut that just slices right through all that complexity. And that shortcut is called a point charge. Now, the official definition is a charged body whose size is very small compared to the distance between it and other bodies. And really, the two words that matter most there are size and distance. And this definition, this is what gives us our superpower. It lets us assume that, and this is key, all the charge content of the body is concentrated at one point in space. We get to take that messy, complicated shape and, just for our calculations, squash it all down into a single, perfect little point. But this powerful tool isn't magic. You can't just use it whenever you feel like it. No, there's a golden rule you absolutely have to follow. There's a condition that has to be met. And that's the million-dollar question, isn't it? When is this simplification okay? When are we actually allowed to just ignore an object's real size and shape and just treat it like a dot? And the rule is it's beautifully simple. It's basically a three-step check. First, you look at the size of your objects. Second, you look at the distance that's separating them. And third, and this is the big one, if that distance is overwhelmingly larger than their individual sizes, you're golden. You can treat them as point charges. And this is why it works so perfectly. Think about an airplane. Up close, it's this huge, complex machine. But from 30,000 feet up in the air, it's just a little glint in the sky. Distance erases detail. From far enough away, the Earth is just a point, the sun is a point, and that galaxy we were talking about earlier, yep, just another point of light in the night sky. Okay, so we've got this clever shortcut, and we've got a simple rule for when we can use it. But why is this one little idea so fundamental? Why does it matter so much in the grand scheme of physics? Because without it, a huge chunk of modern physics would just grind to a halt. The point charge makes impossible calculations possible. It's the absolute foundation for major laws like Coulomb's law because it gives us a single point to measure distance from. I mean, this one idea lets us model everything, from the dance of electrons inside an atom to the gravitational pull between distant stars. It's the ultimate tool for seeing the bigger picture. And that really leaves us with a final thought, doesn't it? If strategically ignoring detail is one of the most powerful tools physics has for understanding the entire universe, where else in our own lives could a little simplification bring a whole lot more clarity?